In this video, we're just going to explore what it is that a confidence interval means. What I have is a data set which is very large, 25,000 people, and I think this was Singapore, Hong Kong, can't remember. I'll put a link to the data when I find it. And because this is such an enormous sample, the estimate here of the population mean is going to be really accurate. So we can almost say that this would be the population mean, 67.99 or 68 inches, rounding off. So if we were trying to estimate a population mean with a sample, we would expect that every time we take a sample, we would get a slightly different estimate just because it would be a different group of people. So to explore this idea, what I've got here is a set of 10 samples of heights and weights. And I'm just going to look at heights, but you could explore the weights as well. Each sample, I think, has got about 100 people in it, and these have just been randomly drawn from the larger data set. So numerically, we can get SPSS to tell us the sample mean and the confidence interval for estimating the population mean. And we can do that just through the descriptives and explore. And you can see that I've popped them all in that, I've put the first three in the dependent list, and we're not splitting by any other variable, so you can just leave that blank. I wonder if we can uncheck a whole lot of, it's going to give us a little bit too much output, but that's okay. So in the output, you'll see that for each sample we get a slightly different estimate of the mean. So 68.14, that's a bit high. 67.7, that one's a bit low. 68.0, so they're hovering around the true population mean. And the 95% confidence interval gives an idea of how sure we are that we have captured the true population value. Now we can graph this to visually get a picture of what's going on, and or maybe I had that up above there. I'll show you how to do that in the graphs and chart builder. I'm just going to cancel, I didn't mean cancel, I meant reset, sorry. Reset. Drag in your mean and error bar chart, leave that on confidence intervals, and you can put in separate columns into the y-axis if you're following along, and just press OK, and then you can actually keep adding them in here and it will create the groups for you. So that's how that works. So what I've got here are the 10 samples all graphed with the sample means and the confidence interval. And they're 95% confidence intervals, which means that 95% of the time we expect to have covered the true value, the population value. Now, usually we don't know what this population value is. In this case, we know it's about 68 inches. So we can see that in each sample here, we have actually captured it. Some of the estimates are a bit high, some of the estimates are a bit low, some of the estimates have a little bit more, some of the samples have a little bit more variation than other samples, so the confidence intervals are a little bit wider. In each case, we have covered the true value with our confidence interval, but if we repeated this process 100 times, then we would expect that 5 of those samples would have just missed the true population mean. The confidence interval wouldn't be covering it. And that's what the correct interpretation of a confidence interval is. That so for a 95% confidence interval, we're 95% sure that we have covered the true value. So the true value doesn't change, that's fixed, it's just that we don't usually know what it is. Each time we take a sample mean, the sample mean will change and the confidence interval will change a little bit, but 95% of the time we think we've covered the true value. And the only thing to remember here is that 5% of the time, of course, it means that we haven't covered the true value. And this doesn't mean that someone has done something wrong with an experiment or a study. It's just the way the statistics works, is that 5% of the time it will be wrong. The problem is we don't know when that 5% happens, because if we don't know the true value, then we can't know for sure whether we've covered it or not. But it's worth knowing that, because it does mean that if everyone uses 95% confidence intervals or a 5% level of significance, which go together, it just means that by the numbers, 5% of all research is wrong, and probably a lot higher percentage is wrong for other reasons, but at least 5% must be wrong just due to the nature of the way the statistics works. So I hope that helps clarify what a confidence interval is. And it's very important that when you're making estimates from your data, and it doesn't have to just be for a mean, you could be estimating all sorts of things from your data, it is really important to put a confidence interval in it, or depending on your discipline, you might use standard errors, but you should be using some measure to communicate how sure you are of this value which you're giving the reader.